Hello everyone, this is Dr. Captain K. Sujata, Professor of Mathematics, St. Joseph's College for Women, Autonomous, Visakhapatnam. In this session, I am going to discuss the Cauchy Euler equation, part 1, comes under linear differential equations with non-constant coefficients. Coming to the learning outcomes, after successful completion of this lesson, the student will be able to solve linear differential equations, solve higher order linear differential equations, both homogeneous and non-homogeneous with non-constant coefficients, solve the linear differential equation by using Cauchy Euler equation, and understand the concept and apply the appropriate method for solving linear differential equations. In the previous session, we have discussed the following definitions and some problems on variation of parameters. The variation of parameters working rule to find the general solution of the given equation by the method of variation of parameters. In case a given equation is not in the standard form, reduce into the standard form. That is the first step. Find the solution of the differential equation. Let it be the solution be y is equal to c1 u of x plus c2 v of x, which is a complementary function of equation 1. Let the particular integral of equation 1 be yp is equal to au plus bv. And after that, after write down the particular integral, then write down the uv dash minus vu dash. Right? After writing this, then find out the a and b values using the given formula. Then write down the general solution yc plus yp. This is a Cauchy Euler equation. So this call it as a homogeneous linear equation as Cauchy Euler equation of order n. So using the Cauchy Euler equation, you have to write down the formulae. Have to write down the take the Cauchy Euler equation can be transformed in a linear equation with a non-constant coefficients with a constant coefficient by the change of independent variable with the substitution. These are the substitutions, right? So coming to the problem. So this is the first problem. First of all, write down the operate using the given differential equation, write down in the form of the operator form, right? Now, after writing the operator form, then apply the Cauchy Euler equation. We will get these are the equation. Now, so from 1 and 2, we can write down the equation. We will get this equation. From that, you can write down the particular integral. So you see in this, this we call it as a q. This we call it as a q. This is a f of theta. So after writing the f of theta, then you can write down the auxiliary equation f of m. Now auxiliary equation, now here we will get the roots of the m auxiliary. From the auxiliary equation, we'll get the these are the roots. According to the roots, we have to write the complementary function. Then after writing the complementary function, you can write down the particular integral. Now in the particular integral, different types are there. In different problems, different types are there. One by one, I will explain. This is in the first problem. This is the one method. So directly if we substitute a, this is in the form of e power a z. Now here particular integral what we have written, one yp is equal to 1 by f of d into e power z. E power z is nothing but q, right? So here e power a z, this e power a z, a value is 1. If you substitute a value in place of theta, if we get 0, so we should not substitute. If it will not get 0, then directly we can substitute, then find out that value. Here we are not getting 0, that's why we substituted. Then we'll get the yp. After getting yp, then write down the general solution yc plus yp. Coming to the next problem, this is another type of problem. First of all, write down the general solution, apply the Cauchy Euler equation. We will get the auxiliary equation. This auxiliary equation, write down the factors. Now, after writing the factors, then write down the complementary function. Then go to the particular integral. Now, here particular integral is this one, m by 1 by f of d into e power a. This is here it is not e power z, it is a q. So q is nothing but here in this particularly in this problem e power 2z into sin z, right? Now here suppose any function is in the form of like this e power 2z into sin z. So what we have to do? So product of the two functions in the form of the exponential function and the trigonometric function. So first write down the e power 2z into, then this is whatever here a value is 2. This is in the form of e power az. So here a is 2. So we have to add that a value to the theta, right? So like this, right? After that into sin z. Simplify that, we'll get the value like this. So this is in the form of 1 by d square plus a square into sin ax. Suppose any function like this, the integral value is x by 2 into integral of sin ax dx. Similarly, if it is a cos ax is a value. So here a square, this is in the form of, here a is 1. This is in the form of d square plus a square, d is theta, a is 1. Right? So a is 1 means what is the formula? X by 2 means x is z here. X is z, a is 1. So x by 2 means z by 2 into integral of sin x, integral of sin z. That is integral of sin z is minus cos z. So minus z by 2 into cos z. Okay. That is about the particular integral. After getting yc and yp, then write down the general solution yc plus yp. Now coming to the another problem, solve x square d square. This is, so first of all write down the operator form, then apply the Cauchy Euler equation. We will get the f of theta like this. Then auxiliary equation. This is auxiliary equation. Here the repeated roots. If it is a repeated roots, then yc is, this is the formula. Then after that go to the yp particular integral. This is a particular integral 1 by f of d into q. Then this is the formula. So if it is like this. 2 into e power z. So 2 write down outside, 2 into 1 by, this is in the form of theta minus 2 whole square. So any function like this, 1 by d minus a whole to the power of r into e power a z. So we have to apply the formula is z to the power of r by r factorial into e power a z. Just I will explain on the board. I will take the pen. Right, so this is a 1 by how to write, this is in the form of like this. Just write down 2 outside. This is in the form of 1 by theta minus 2 whole square into e power 2z. Okay, so use this formula. Here a is equal to 2, a is equal to 2, r is equal to 2. Okay, so what is the formula? Z power r, z square, r is 2 by 2 factorial into a power 2z. Okay, so already 2 is there. So multiply with the 2. So 2 gets cancelled. What is the value we got it? Z square into e power 2z. Right? Z square into e power 2z. Right? So according to this formula, you can apply the, you can simplify this integral value clearly. So in every problem I have given the that solution, that formula I given. According to that, you can do the problems. Right, after getting the yp, you can write down the general solution. Y is equal to yc plus yp. I'm going to erase this one. Right, now coming to the next one. Coming to the fourth problem, solve x square d square. This is a differential equation. Write down the Cauchy form. After that, write down the auxiliary equation. So okay, again repeated roots. So this is a yc. Then write down the yp. This is another type of the yp. So here this can be written as like this. So we have to apply the binomial expansion here. So how to write the binomial expansion here? Again, I'll explain fast using the pen. So how to write this? This we have written. So this can be written as 1 by 1 plus theta square minus 2 theta into 2z. Okay. So this can be written as 2 into 1 plus theta square minus 2 theta whole inverse into z. Right. So use a binomial expansion. Treat this one as a x. So this is in the form of 1 plus x whole inverse. Means 2 into, what is the formula? 1 minus x. 1 minus x plus x square minus x cube. So 1 minus of x minus 2 theta. Remaining plus whole square and so on. So anyhow we'll get 0. If we apply theta is nothing but d by dx, no, derivative. Theta is nothing but derivative. So d by dx are d, differential operator. So if we apply the next whole square, no, so we'll get, if we apply the differentiation, we'll get 0 because simply it is a functional value is z. So simplify that 2 into, expand with the z minus theta square into z minus into minus plus 2 into theta into z. Right? So this is nothing but 2 into, so here z minus 2 times we have to differentiate. So value becomes 0. So this is the, we have multiply with the 2, no? So plus 2 into derivative of z is 1, right? So expand with this 2z plus 4. So this is the required value 2z plus 4. Okay. So according to this formula, we have to apply this one. So that is about the explanation. I am going to erase this. right? Now coming to the, after getting yp, then write down the general solution, right? Now coming to the fifth problem, this is another type. First of all, write down the apply the Cauchy Euler equation, then write down the auxiliary equation. Here the real roots we got it according to the real roots, then write down the complementary function, then write down the particular integral yp. After getting the particular integral, then what we'll get, yp is equal to 1 by f of d into e power. This is the q value. Then so this can be written as, this is another type, 1 by theta square minus 4 into e power 2z, right? So here I will explain. We have to apply this formula here. So how to write this one? So here if we write this one, 1 by theta minus 2 into theta plus 2 into e power 2z. Okay. So if we substitute 2 value, that is a value in this, if we substitute a value in this, we'll get this denominator becomes 0. No, that's why we should not substitute directly here. First we have to write down that this will, if we substitute 0 వస్తుంది కాబట్టి దీన్ని బయట రాసేసి remaining write down here 1 by theta plus 2 into e power 2z. Okay. Now substitute 2 value in this. It's 1 by theta minus 2 as it is గా ఉంచి ఈ 2 ఇందులో సబ్స్టిట్యూట్ చేస్తే 1 by 4 into e power 2z. 2 ఇక్కడ సబ్స్టిట్యూట్ చేయండి, 2 plus 2 4. ఓకే. సో 1 by 4 బయట, ఇప్పుడు దీని లోపల తీసుకెళ్తే 1 by theta minus 2 into e power 2z, రైట్? సో దీన్ని ఎలా రాస్తాం, 1 by, ఇప్పుడు ఈ ఫార్ములా అప్లై చేయాలి. ఇప్పుడు చూడు ఇక్కడ మనం 1 by d మైనస్, ఇప్పుడు ఇది మనం ప్రీవియస్గా ఫస్ట్ ప్రాబ్లంలో మనం అప్లై చేసాం సెకండ్ ప్రాబ్లంలో. సో దిస్ ఈస్ ఇన్ ద ఫార్మ్ ఆఫ్ 1 by theta minus 2 whole to the power of r. R value is 1 into e power 2z. A is 2, R is 1. So what is the formula? 1 by 4 into z to the power of r. Z to the power of r and r 1 kada, 1 by r factorial and 1 factorial into e power 2z, e power az, right? So this is the value is 1 by 4 into z into e power 2z. Okay, that is the way we have to do this problem. So clearly I have given how to do this one. So I'm going to erase, right? Coming to the, after getting yp, then write down the particular integral. After writing particular integral yp, then write down the general solution yc plus yp. With this, I'm going to conclude this lesson, this session. In this session, we have discussed the Cauchy Euler equation and its applications part 1. The Cauchy Euler equation, this one, these are the Cauchy form, Cauchy Euler equation form. So substitute in the given differential equation, we will get the auxiliary equation, right? Thank you. With this, I'm going to close this session.